All right. I'll start again. Good morning, everyone. I'm Nitish Mane. I'm a software engineer working as a platform engineering team in Philo. Philo is a video streaming platform. We have a B2C app where we stream live TV, where users can, watch uh, like we have multiple networks who we are contracted with, and you can watch a live TV over there. But today's talk is going to be not about my work at Philo, but something which I did in my previous job. I used to work at a Lucid Motors before Philo, and we had pretty interesting challenges which we had to solve during my time. So I'll be talking about, hub and spoke, app of apps and application sets in Argo CD. And by the end of this, you will have a mental model and a companion repo on GitHub you can clone and play with. Uh, Let me see. Am I sharing my presentation? Okay, yep. Let's move on to the next slide. Okay. Uh, so uh, I'll first talk about, why we are having this issue, right? Like when we are working on a large organization, you have multiple BUs, they operate in multiple regions, and every BU, right, business unit, they want to have their own dedicated environment where they want to deploy their applications. And sometimes uh, when the business grow, they want there you will end up in a challenges where you have to deploy your environment where a vendor is not available. For an example, AWS is not there in Saudi Arabia, right? So you will have to choose between a different cloud provider that you have not worked with. And when you are managing multiple regions and multiple cloud providers, you will get into a scenario where uh, you have if BU has like 10 plus microservices and uh, they have like a dev stage and prod environment, and then you have three clouds you're working with AWS, OCI, and then it just become I would quote multiverse of madness. How there's a multiverse of madness movie in Spider-Man, where you are managing so many deployments you don't know how to proceed, right? Let's move on to the next, right? And then what happens is, uh, how do you scale without breaking consistency, right? Each environment has their own DNS, right? So internally, if you have worked on these multiple regions, you may notice it's easier to have like a DNS which are relatable. So the engineers who are working on it, when they open a particular app, a DNS will tell them you know uh, uh, which region they are working with. You have secrets management in different clouds. You have ingress classes and image types. So, and sometimes you get asked with how do you handle environment specific overrides, right? For an example, you have this you do not have lot of users in, let's say, EU region, so you want to have a limited capacity. There is some workload which is not on auto scaling where you have to pre-scale, right? So how do you have an environment specific overrides when where you're anticipating more load? And when you are setting up your alerts, you also want to set up different thresholds for different region, right? Because In KSA, the threshold might be different. In EU, threshold might be different, and then in West Coast, it will be different. And then one other challenge which you get is how quickly you can set up these environments, right? You will get asked by a company like, hey, we want to expand to, let's say, AWS China, right? How quickly we can start there. And so the answer for that, all of that is what we're going to talk about. Uh, so six things. So let's move to the next slide. Six things which we'll do is the GitOps. Let's go to the quick GitOps refresher. A hub on and scope architecture, app of app pattern with pre-environment value story, what is the application set and the evolution, and then some of the best practices, right? So that's the agenda for today's discussion. Let's do a quick GitOps refresher. I know since morning you must have heard this term a lot, but I just want to go it one more time that because it's so important to have the changes in the code, and when you have so many teams working across different time zone that you lose a you will come across situations when there are PRs open with the diff and nobody can solve them because they don't know what it could break. So that's why it's important to have GitOps where you declare you hold Git as a source of truth, where you declare your Terraform, YAML, or any other code, right? And then Argo CD continuously defs it and checks against your current cluster state and self heals or reconciles. And then every time somebody wants to push any changes, they open a PR, and then you make sure that there are some dedicated engineers who are senior enough who can review those changes, make sure they are according to the best practices. There's not uh, those changes are not you know could cause any uh, issues for any other environments, right? And you want to have this minimally defined. For an example, if you want to uh, yeah, that's the story. So how in the smallest way you can make those changes as possible. Now when we looked at this problem, right, we decided to look at one single Argo CD instance, right? One single Argo CD instance deploys applications across or for all these BUs across multiple regions. That's what we decided in the beginning. But as you can see, this is not very good design, right? Because we started to get issues because Argo CD will st- start having problem. When you open the UI, it will not sync properly or sync is just running forever. And then it also creates like a big blast radius, right? Because if a single Argo CD goes down, you will see like on the UI that none of your apps are nobody from other BUs are able to deploy applications. And you also have to make sure that Argo CD is accessible at L4 level. So you have to expose the kube API server from all these Kubernetes cluster to the central Argo CD, right? And then RBAC sprawl because you have so many teams which you have onboarded and they are deploying applications, and it's just too much to to handle. So the the design which we decided to move. So this was our initial idea on how to proceed, but we saw the problems and then we uh, found a solution that is the hub and spoke model. So what we did was we deployed a hub Argo CD, right? And then let's call it a control plane, right? And then every Kubernetes cluster that we had 50 plus Kubernetes cluster. Every Kubernetes cluster will also have its local Argo CD, which is, in charge of deploying application to that particular local Kubernetes cluster, right? The hub or the control Argo CD's job is to create those Kubernetes cluster. And there are some tools available today, open source technology like Crossplane or Cluster API, uh, which allows you to, you know, create Kubernetes servers or manage them, including upgrades using as a YAML file. So you install a CRD and they keep on creating Kubernetes cluster for them. Upgrade is important. I'll come back to that later. Uh, because in the initially we decided, okay, let's create these clusters using Terraform. But with Terraform, we soon hit a limitation that was the diff issue because somebody had an access to to the AWS console and they had changed the node groups or some ports are open and it would create a diff and then it was just not very easy to manage. And with this hub and spoke, it also allowed us to uh, the benefit was the blast radius if anything had to happen for the Argo CD. So for an example, if you upgrade the Argo CD itself, the blast radius was limited to that particular cluster, the local Argo CD cluster, right? And Kubernetes environment itself is very cloud agnostic. So you could have K8s cluster in GCP, OCI, or in AWS, and then they all could be controlled using a hub Argo CD. So that was the design we decided to use. Uh, Now let's build it. Uh, how we can, install the hub Argo CD and the spokes Argo CD. So the 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 hub Argo CD, right? We still had to write some kind of a code, right, which deploys the hub Argo CD. Yeah, I see a question. What is the hub Argo CD managing in this case, right? Hub Argo CD is basically a control plane Argo CD, which manages all the child clusters or K8s environment in this case. And what deploys the hub Argo CD, right? That was the first question which you come to my mind, right? So we wanted to avoid using like kubectl, you know, commands to deploy this hub Argo CD or helm install command. So we decided to go via Terraform route for this hub Argo CD, where it would get deployed as a resource. And once that comes up, you start adding the spoke Argo CD. So the spoke clusters, I would say, instead of Argo CD, I would call them clusters. So the spoke clusters would then get created using Cluster API or Crossplane, right? So it's important to have, you know, uh, and you will. So when you have like 50 plus clusters you are managing using a hub Argo CD, you will start seeing issue. First thing is you want to make sure that it has HA mode. It has more than 2 replicas. It will be slow. So you must have external Redis instance. You need to have sharding done for the backend DB. So the performance is improved because otherwise when you open the UI, it will just keep on spinning and none of the pages will load up. So those are some of the challenges which we face for our hub instance. And let's move on to how spokes connect to hub, right? What happens is now, how do you connect the spokes cluster, right? On the main control plane cluster, you could do Argo CD cluster add, right? That's one way. But we wanted to again avoid or get away from and running any command and had to be declarative. So Argo CD allows you to create a cluster type secret. So when you create that secret, it recognizes that cluster and it will show up under the clusters bar in the hub control plane server. For AWS, if it is a EKS cluster, it will be AWS auth config. If it is a OCI or GCP cluster, it will be a config, the CA certificate for that, the spoke cluster. And once, so, okay, now let's take a step back. How do you create the spoke cluster, right? It depends on what tools are available to you. Uh, I'm not following up much with Crossplane, whether they are available on all the cloud providers, but for OCI and Google Cloud, GKE, you have Terraform, which is very strong. You can still go with the Terraform. And then once they come up, they connect with your, control plane cluster, which will then manage them, right? All right. So once you have this, skeleton ready, where you have like a control plane cluster and then this child cluster, then we move on to deploying the application because you want to run some apps as well, right? Not just create these environments. So the easiest and fastest way to get them running is by using app of app pattern, where you have like one umbrella. When you have like an parent app, which is an umbrella application that deploys all of your child apps, and then folder is just bunch of the parent has a Helm chart whose templates folder is a bunch of Argo CD applications manifest, one child per service. And then once you apply the parent app, it automatically, creates those n child apps. What you get out of such pattern is modularity. Child evolves independently, and you can have per team repos. Uh, Parent can point to children in different Git repos. For an example, let's say if you have uh, a parent in a one repo and you have these BU specific repos where some team is creating their own repos, so parent can point to which repos, or they can point to any GitHub help chart as well, which is open source. And now when you have this app of a pattern, uh, you will see some, sometimes it's easy to uh, create these applications, but sometimes let me first show you what this directory structure will look like, where uh, you know applications are created. Uh, so you have this standard Helm chart with the chart.ml file at the top, and then you have slash templates folder where every file is the Argo CD application manifest, like app one, app two, and so on. And then for each environment, you will have the values file. You can be more specific for and try to name them so they are easily recognizable. You can add suffix like dev, staging, or prod, or you can also try to add some regions to them and a cloud provider because you may have like a dev in OCI, you may have staging in GKE, something like that, and region as well. Helpers.tpl centralizes label, so it's easy to understand when you are creating PRs and sending it to somebody. The reviewer knows which environment it is going to affect, right? So it's important to name them uh, with something which is meaningful. And then three things to call out here is Template files contain help templated application manifest with the blacklist guard at the top at each file. So you must, if you notice, I had mentioned that sometimes you may want to not deploy some applications in some environments and in some regions. And DNS names, let's say you have a Grafana dot acme dot usc2.com, then the same pattern will the same DNS name will be applicable to all the ingresses which are deployed in that region. The only part which will change is the prefix part, where it is Grafana or some XYZ, XY, some app, right? And then image tag, ingress class, and secret references. Now, let's take a look at one of those child applications. This is app1.yaml. Uh, Notice there are three highlighted parts. Uh, if not has, so basically in the child app, you can have like a app1 as a key in the parents value.yaml, and then you can then check whether the parent has whitelisted this app to be deployed or not. And you can have some more keys there like prod or uh, dev, staging, and some of the whatever keys you want to define, you can define in the YAML. Let's move on. Just want to make sure we are on the same slide. Are you, which slide we are on? Okay. Can you move to slide number 13? I think I kept I went way ahead. Okay. Now what happens is uh, you have these two values file. One is for prod, and which basically you can pin a different image tags if you want to upgrade any image tag in the prod, whereas in dev you want to have latest as an image tag because you are developing something actively. And then some of the other keys which you will notice here is DNS, which is example.com. It should have some more it can have some more DNS ability to be to be more verbose. And now let's move on to the app of app. So app of app was great, right? As you noticed, it gives you a lot of flexibility, and it is minimal enough that it can be, it is minimal enough that people who you onboard onto this platform, they understand, okay, this is how it is working. But what happens is now, once in a while, you will be asked to onboard a new, uh, you know, new product altogether to all the environments and all the regions, right? At that time, what it means is you have to create those app of app, you have to create those values file, new keys everywhere, right? Which is not very easy. So that's where application set comes into picture. Uh, it is a different way of creating applications in Argo CD. The generator logic is really powerful. It has a different generator. This is an example of application set, slide number 14, which produces application which matches, the cluster. It can be a matrix, list, get, and pull request generator. Uh, when in the live production system, you will have both patterns, and it depends on the ease of use which your company is comfortable with. Uh, this is a matrix generator combining list and cluster generator. A list has four charts, right? Argo CD, DEX, KPS, and external DNS. Cluster selects every cluster select label managed to true, and the matrix takes the cross product with four charts, and then it will get deployed into 12 clusters. So you get 48 applications generated from one application set, right? So that's why it is sometimes it works better than app of app. Now let's bring it all together. Uh, how does a new environment come online, right? So when we get asked, right, hey, we need a new region in, let's say, Mumbai, and we want all our use cases to be deployed there, your step one would be to spin up that EKS cluster, which will give you a kube config. Step two would be you will create a PR and create that secret into the hub, right? The hub knows now that there is a cluster which has come up, so it will try to look for the value file with the, let's say, Mumbai prod on it, right? And then that's step three. You drop that values file Mumbai hyphen prod on it, and in the step four, uh, you merge it. And when you do that, all the applications which you have defined using application set and app of apps will start syncing, and all the your environment will be alive in no time. It will take maybe 2 or 3 minutes. Uh, that's the happy part. But you know, some of the things there are some of the things which you have to make sure that auto sync is always on and the selfie is always on. Um, we have to make sure that there is no bug, and then the project scope has RBAC, and then the keys which you create in the app of app structure has to be have a meaningful name, right? You have to have namespace isolations as well per app, and then you also have to maintain the taints and toleration. The reason you need this is when when you are doing cost optimization on this entire setup, you want to be able to identify how much money you have spent on use case A versus B. So this namespace isolation will come in handy because it will have tags which you can query from your cloud providers. Uh, and then the Argo CD, multiple replicas. It has to have external Redis, durable repo cache. So some of the anti-patterns we paid for is, having like a big giant repo with all the Helm charts was not scalable because a lot of PRs open there and it was not very easy to manage them. So we decided to split it per BU. So business specific unit have their own repos, and then platform engineering will have their own repo where we maintain our cluster API, Terraform, that type of work. Make sure the environment keys are, templates are created correctly. There is a variable in them so that when your hub installs the spoke cluster, it able to find the key. Never use latest in the prod. Always pin it to some SHA. Maybe for dev work it is okay. And then I wanna move towards how I see this project going further. So now that a lot of all these tools that I talked about have MCP servers, right, which exposes bunch of data for you to gather. And if you right now we I have there is lot of happen there are many new companies or vendors coming in this space. So this technology is pretty new, but LLMs are able to understand the data which MCP is exposing, and they are able to, you can make a use of them to deduct why a particular app is not syncing, why this, um, pod is not getting launched. So there is a lot of scope for AI usage here. Uh, LLMs are also very good at creating YAMLs and uh, finding any bugs in them. All right, let's move on to the next one. 5 things to take home is hub and spoke Argo CDs. First one is hub and spoke using Argo CD at scale, and hub holds the intent, spokes own the local reconciliation. App of app gives you the composition. One umbrella app declaratively owns the whole environment. Third one is applications sets are a powerful way and gives you leverage to deploy multiple apps using a single YAML file. Fourth one is templates are variables, but the values files are where you will define your cluster state. And fifth one I want to talk about is GitOps is a AI safety net, right? You have to make sure that uh, no matter how much AI or MCP you are using, you have to always follow this GitOps principle where you create a PR and you review the changes before pushing them. Uh, yep. And then I have shared this demo repo on my GitHub uh, link. Feel free to clone it. It has this some of the README docs and the source on how we came to this repo. Uh, Thank you. If you have any questions, I'm free to take them now. All right.
I apologize. I was muted. How would you automate the deployment of Argo CD to a cluster?
Which one is that, hub or the spoke one? So for the hub one, you have to have Terraform, and for the spoke one, you deploy them as a application set. So every time the cluster joins, you deploy set of applications on the spoke clusters, and the set of apps is nothing but observability stack, SSO stack like Dex, and then Argo CD, local Argo CD itself.
Perfect. All right. So just because we're short on time, I'm going to cut it off there. But I want to thank everyone for coming to this discussion, and feel free to take a look at the agenda to see what's coming up next. Nitish, do you have any other parting words?
Yeah, I want to say if you have any questions about how to implement this or how does this work, what kind of technologies to choose from, how to handle cross cluster work, feel free to contact me. I have shared my LinkedIn. You can always message me. Yeah.
Awesome. All right. And everyone have a great day on the session now.